and lifting it off. This is going to be a lot of noise, but just take a look. Music's going to start. Ladies and gentlemen, take a look as your United States Marine Corps F-35B Lightning II is converting to the short takeoff vertical landing mode, or STOL mode. The door at the top is the intake for that vertical lift fan. 2 doors below will open up. So the lift fan, which is being powered by that F-135 engine from Pratt & Whitney, and the doors at the back to vector the thrust from the tail with the thrust. This is the show, but that said, you might be able to modify it a little bit.
Hopefully the weather clears up and we get some blue sky above us. But right now it's converting outbound, so we're working our STOL conversion. Once you're airborne, you get into the conversion envelope about 180 square knots. It's able to convert back to language on conventional. Once you're conventional mode, fly like a regular fighter jet.
Now, it also has some advanced data fusion capabilities. And they are unmatched anywhere in the world because of the way it can transmit, assimilate, and transmit data to other platforms. Tell us a little bit about how that functions.
What it ultimately does is that the jets are shared information. Everything is being presented to the data, presented to the pilot in seamlessly. Makes our lives easier, makes us able to complete that kill chain faster.
From the right, you'll see it come by. Looks like a high-speed pass. Watch as it approaches. Tiny's going to sharply bank to the right and do what is called the minimum radius turn. So it comes. That have been built by Lockheed Martin, most of which coming off the production line in Fort Worth, Texas, where all 3 versions are made. Approaching the speed of sound will be the next pass that we'll see. He will not exceed the speed of sound, but this 5th generation fighter with that Pratt & Whitney engine can get it well in excess of Mach 1. We don't want to exceed the speed of sound because it would knock windows out and who knows what all. Here's from the left. Here's the right. The F-35. This is a miracle, not only in terms of the technical abilities and challenges that had to be overcome to manufacture this airplane to make it work for the Navy, for the Marine Corps as well as the Air Force, but also Netherlands and Canada, Australia, Denmark and Norway, and then other aircraft, other countries have purchased it, like Israel and Japan, the Republic of Korea, Belgium, Poland, Singapore, Finland, Switzerland, Germany, and the Czech. Is at the controls, and Cricket was mentioning how they assimilate the information. There is the capability in this aircraft to assimilate or take in an incredible amount of data over the battle space, but it is refined, and then a lot of it is projected on the visor inside the helmet, right, Cricket?
And that's the biggest step forward from Porsche, or one of the biggest step forwards, where now instead of looking at multiple displays, I'm looking at one display that seamlessly ties all that data together with very minimal input on my behalf.
Now let's watch how quickly he can change direction. This is called the tactical pitch. This airline carries the moniker of two very, very classic airplanes, one from World War II, the P-38 Lightning from the United States Air Force, which was the mount, the aircraft flown by America's leading aces of World War II, and also the English Electric Lightning. Now, one of the things that keeps this aircraft stealthy is the fact that it carries everything internally. Watch as it comes by and opens the weapons bay door. The helmet that a pilot wears in the F-35 Lightning II is actually, I think it costs more than the median cost of a house in the United States.
It's hands down the most expensive thing I've ever worn in my life.
You mean it's more expensive than that fancy suit that you had on the other night?
This whole thing, we just threw these on this morning.
The helmet is worth about $450,000, and it is molded to your head and balanced so you can withstand the G-forces. Now, he's gone through fast. What's he going to do now?
So now trying to setting up with these slows, high alpha pass. So right now it's slowed down about 105-ish, 110 knots. We're looking at 33, 34 alpha. So max performance in the slow speed, high alpha claw.
When we say alpha, that means angle of attack. It's quite simply the number of degrees that the nose is pitched up above the horizon. This is fantastic for a 45,000-pound aircraft. and the ability to what they call work interoperably with other nations would literally allow a Marine Corps pilot like Tiny, like Matt Johnson, to identify a target some many miles away, transmit the information on the target's location and the type of target that it is to another, maybe say an Italian F-35 Lightning II, and that Lightning II could sneak in undetected with passive radar and passive sensors and destroy that target, putting nobody at risk. I am blown away by how amazing this airplane and these airplanes are as he rolls it on its back for an inverted pass. And so similar are these airplanes. I have been told, Cricket, that a pilot of an F-35, if he or she were blindfolded and sat down in any one of the models of the F-35, and then the blindfold were taken off, you really wouldn't know initially what model you were in. Is that correct?
That's correct. A lot of the hardware is identical between the Alpha, Bravo, Charlie. The software is identical. The jet knows which one is flying. Going between the jets, we do series conversion. All it takes is really a couple flights to get familiarized with the different platform. Going to the Bravo, probably the most complicated with the STOL emergency procedure considerations we have there. But overall, they overlap.
It really is amazing. I've heard arguments about that, but when I talk to the pilots, every one of the pilots I've talked to says they are so similar, and yet the ability of the Navy version to land on a carrier, it's beefed up more for that. The Air Force Adrian Pittman and Betsy Clark, three people who were involved in the program since its inception, that tells the story of not only the development of the aircraft, but how difficult it was to get the partner nations on board so that not only the United States, but other countries could be partners in the manufacture of systems for this transformational jet. There is nothing out there that our enemies can counter this with. Tiny is now going to slow down, and he's going to open the doors, the STOL doors. He gets slowed down, he's got a button to push, and the door on the top will open up. That's the intake for the vertical lift fan system. And the doors on the bottom will open up for the exhaust for the lift fast system. And then two doors at the back so that the rotatable nozzle can be used as well. Cricket, that the aircraft came in at about 45,000 pounds. What kind of thrust does that Pratt & Whitney F-135 engine produce?
So I've been told by some of the Pratt & Whitney engineers who worked on the jet, had the pleasure to speak to them at an air show, but it puts out about 44,000 pounds of thrust. Bravo actually gets the most thrust between the three domes.
So it's pretty much a 1-to-1 thrust to weight ratio. So if it's running a little lighter than 45,000 pounds, it could accelerate going straight up, right? Ballistic, maybe?
Maybe on a nice full day like today.
Okay. Now he's coming through slowly. What's going to happen now, Cricket? He's going to be, well, what we'll see is the ability of this aircraft to hover.
So from right to left, we've got Tiny. He's in STOL, so mode 4. Got all the doors open, geared down. And now he is about to execute his decel. So about 0.6, 0.7 to run show center here. He's going to select idle.
How about an incredible round of applause for the F-35B Lightning II? Cricket, thank you so very, very much for your commentary. Having a pilot talk about it.